My name's Tim Ward. I'm an engineer at a company out of Copenhagen, Denmark called CluedIn. I'm originally from Australia, but I moved to Denmark essentially to work with a good group of people, engineers. My background is mainly in engineering. I've been a software engineer for 12 years. Typically quite a polyglot developer, trying different platforms out. And that's really what brought us to Neo4j, a different type of technology that was worth investigating. So at CluedIn, we take a very polyglot design to our technology stack. So we actually use a whole different variety of different databases, and the way that we use Neo4j is actually as our primary data store. It's really based off this idea or ethos that we have that connected data is always more interesting than disconnected data, especially when you're wanting to do something like we do, where we're integrating data automatically from different systems. It requires this kind of database where context and the graph theory itself and the design patterns that are in it are really just, necessary for solving this problem to a higher precision than the other types of technologies we're used to. So I started Neo4j close to 6 years ago, and I started on a very kind of early 1.5 release. And I think the interesting reason we were looking in the graph space was because of the new possibilities and engineering techniques it gave us, to work with a different data structure that solves problems that, inherently other data stores you would typically bend to solve the same problem. And I think that the three kind of main points why we chose Neo were its ability to join across huge amounts of data, no matter the kind of depth of the connection. The next was the pattern matching techniques, and finally it was actually the kind of path traversals, the ability for us to kind of take two discrete nodes that were in our graph and to reverse engineer the connections between those two data points. Neo4j, of course, for us, when we were looking in the market, it just seemed like the obvious choice. It had a fantastic company behind it. It had a lot of growth. It had some funding, which we knew that could, that technology could get the right, the necessary attention that needed to fulfill the graph story. So I think that and the combination of it integrating well with our stack and having the APIs available for us to work with it in an agnostic way, no matter what libraries we were using or languages, really helped it an easy choice for us to choose Neo. So I think the most interesting results that we've had were our scale story. So our story of how we started off with 15 customers and how we grew it to a database of 280 million nodes right now with close to 1 billion vertices or edges in the graph. And I think what surprised us and that also challenged us was the resilience behind the platform, and that being a generic graph model, you could really take control of the platform in the parts where potentially focus was needed from the product, especially around things like indexing and scaling using a schema instead of, we went through this kind of era in the NoSQL area where, no schema was something that was sold as like a big plus. And what you really realize when you go to production is that, well, a schema is actually something that's extremely necessary, and that our ability in Neo to be able to influence how the core platform actually worked with things like indexing, I think it was the flexibility that surprised us in a very kind of positive manner. I think what we realize after time is that, well, there are some odd things that you might need to do with your model to cater for some of these scalability type of complexities that come. And to be honest, only really show themselves when you are in production at huge read and write levels, concurrent read and write levels, and you're also dealing with such a diverse amount of data that's not necessarily fitting all into the same model. We work, with different customers' data, and one customer's industry looks completely different to the data from another industry. And the ability to have a model where at a later point we could bend and change, I think that was one of the things we would probably revisit. But I mean, in hindsight, maybe we wouldn't have discovered that if we didn't go with our original easy way of modeling the data. we're on a very similar mission to Neo4j, which we're wanting to connect the enterprise, and we're using a lot of the same techniques that Neo4j is also saying that's in their vision. I mean, using machine learning techniques as well. So where we see really the market going is that a lot more people are adopting graphs as just one of the extra types of databases that you can use to solve problems. And I think where it's going is that the application of machine learning combined with things like the graph to be able to kind of produce results where companies can actually start to utilize their data properly. They can become data-driven, and we can get out of these kind of archaic ways of manually integrating systems in a very tedious and manual approach, and move towards a company's data telling us how things are connected. Maybe even the fact that models in the future for the graph will be inferred from the data instead of the other way around. So I'd like to see that's where it will go. I mean, my final thoughts would be that I think Graph Connect is a fantastic way to, talk to the people from the product team, to give them feedback from the field. I think there's huge value in being able to, take our huge production environment and talk to the actual engineers that can change those things, that can actually make a tangible impact on allowing companies like us to be able to scale to some of the biggest companies in the world. So I think that's kind of priceless.